Good morning. Now we start chapter number 10, Circle. In standard 9, we learn about circle. What is circle? Here we learn some important points. Circle, its chord, center, radius, diameter, segment, sector, second, tangent, and points are parts of circle. In this chapter, we learn more than some solution, solve some example by these properties. Now, important points of circle. For remember, you write in your notebook and remember these points. For calculating sums, when we use this point, use these rules. Number 1. A circle is the set of points in a plane which are at the same distance from a fixed point in the plane. The fixed point is called the center of the circle. What is center? Circle is a set of points. Here like this, circle is a set of points. There is infinite points. Then we draw a circle. Points in a plane which are at the same distance from a fixed point. We put compass here and then draw this type of circle. It is the same distance from the fixed point. This distance is same from the fixed point. Suppose this point is O. Then this distance of this, suppose it is 4 centimeter, 4 centimeter, 4 centimeter. All these points, set of all these points is called circle, and this fixed point is called center of the circle. Now what? Center of the circle. The distance of one endpoint is center of the circle and other endpoint is on the circle. One endpoint is the center of the circle and other endpoint is on the circle. Then it is the line segment is called radius. It is called, now we learn center with number, then radius. One endpoint is center of the circle and other point is this, then it is called radius. In circle, all the radii having same measure. Suppose it is 3 centimeter, then it is 3 centimeter, it is then 3 centimeter, 3 centimeter. Now what's chord? We learn in standard 9. What is chord? A line segment whose both endpoints are on the same circle, then it is called chord. Suppose like this, it is called chord. Chord is a line segment whose both endpoint on the circle. A chord passing through the center of the circle is called diameter. A chord, here is a chord passing through the center of the circle. It is called diameter. You know all these terms. Diameter. That is, diameter is 2 radius. Its measure is equal to 2 radius. 1 radius here and here, then 2 r. Diameter is equal to our formula 2 into radius. But 2 into radius not becomes radian. Not becomes diameter. Diameter is equals to 2 into radius, or radius is equals to diameter by 2. Divide by 2. Okay. Center, fixed point is called center. Radius, the one end point of the circle, one end point is the center and other end point is on the circle, then it is called radius of the circle. Both end point on the circle, then it is called chord. A chord passing through in the center of the circle, then it is called diameter. Diameter is the largest chord of the circle. Diameter is equals to 2 into radius. Now, number 2. Other point here. 3 non-collinear points always determine a circle unity. 1, 2, 3. It is collinear point, then it is not circle, not become circle. But suppose 3 non-collinear point, then passing through this circle. 3 non-collinear point determine the circle uniquely. 3 non-collinear point determine a circle uniquely. That means a circle, one and only one. A point, 3 non-collinear point determine only one circle. It is, suppose these 3 determine another circle, but here it is one circle. 3 non-collinear point, it is necessary condition. To determine the circle, 3 non-collinear point we want. We want 3 non-collinear point which is determine a circle unit. Next number. Congruent arcs of circle subtended congruent angles at the center of the circle. What is arc? We know arc is a part of the circle. Here suppose it is a arc AB. It is denoted like this arc AB. It is minor arc. Then included center it is major arc. Major arc AB, it is minor arc AB, and suppose it is on semicircle, then it is called semicircle arc. Length of each arc, both arc is equal. Semicircle arc in both arc is equal. Length of minor arc, formula. In standard 9, we learn length of arc is equal to length of arc is equal to R. R is equal to pi r theta upon 180. Suppose we multiply, we calculate some sum. Therefore, we use this formula. L is equal to pi r theta upon 180. What is theta? Theta is angle included subtended by r. Then it is called theta. Pi r theta upon 180. Now, in this topic, we know this. In this topic, congruent arcs of a circle subtended congruent angle at the center of the circle. Suppose here are congruent arc AB, O is the center, and CD is also congruent. Congruent, therefore, then measure are equal. Congruent arc of a circle subtended congruent angle at the center. Subtended congruent angle, that means this angle AOB and angle equals to angle COD, both are congruent. Suppose here PQ is the other congruent arc, therefore angle POQ are equals to equal. Okay. Again these topics. If congruent arcs of a circle subtended congruent angle at the center of the circle. Congruent arc subtended congruent angle at the center of the circle. Next number. The angle subtended minor arc at the center of the circle has double the measure than the measure of angle subtended by the same arc at a point on corresponding measure arc. It is like this. The angle subtended by minor arc at the center of the circle. Here, AB is a minor arc and O is subtended angle AOB. Has double the measure than the measure of the angle subtended by the same arc. Measure the angle by the same arc at a point on the corresponding measure arc. Its corresponding measure arc AB is minor arc. Here it is its corresponding measure arc. Point on subtended. Suppose P is the measure arc point. Point P is in line on measure arc AB. Then angle AOB is equals to 2APB. Is twice subtended by the same arc at a point on the corresponding measure arc. Double. Suppose this angle is 50, then in this angle is double than the center, at the center angle is double 50, then it is 100. And in this sum, POQ, it is 160. Then find P and Q. What is the measure of this? Here is the double. It is half. Then in 9th standard we prove this theorem. It is 160 and half of it is 80. Then we see that PMQ is equals to angle P and POQ is equals to twice angle PMQ. Center is the double, then other one. Therefore, 160 is equals to 2 into angle PMQ. 160 divided by 2 is equals to angle PMQ is equals to 8. In this formula, we put here 50, 2 into 50 is equals to 100. Okay. Angles in the same segment of a circle are congruent. Angles in the same segment of a circle are congruent. What is segment? Segment, that means it is called segment. An arc and chord is corresponding chords making prepare including a segment. It is called minor segment and this is called major segment. Angles in the, we learned this all in segment standard 9. Angles in the same segment of a circle are congruent. Same segment of a circle are congruent. Suppose here it is a segment AB. Then angle this ABB and suppose here Q AQB, here R, then ARB. On same segment, angles are equal. Angles in a same segment are equal. Suppose it is 40, then it is 40, then it is 40. Okay. Next number. Angle inscribed in a semicircle is right angle. It is most important for your MCQ question. We use here angle inscribed in a right angle in a semicircle. Suppose it is a semicircle. Here we draw a circle. It is a semicircle. Angle inscribed in a semicircle. Inscribed, that means in the angle. It is right angle. In a semicircle is right angle. The sum of measure of opposite angles of a cyclic quadrilateral is 180. What is cyclic quadrilateral? In circle, of vertices of all the vertices of quadrilateral are lying on same circle, then it is called cyclic quadrilateral. Here it is called cyclic quadrilateral ABCD. Suppose it is called then we see that P, Q, R, S. All vertices of this quadrilateral are on same circle, then it is called cyclic quadrilateral. The sum of measure of opposite angles of a cyclic quadrilateral is 1. Sum of opposite angle of cyclic quadrilateral is 180. It is 80, then it is 100 minus 80. 180 minus 80 is equals to 100. Suppose this angle is 30. Then what is the measure of angle T? 150. In question, this question, PQRS is a cyclic quadrilateral. Then angle P is equals to 65 and S is equals to 80. Find and other angle. Then we see that 100 minus 80, angle Q is equals to 100. 65, 100 minus 65. Oh, sorry. 180 minus 80 is 100 and 180 minus 65. 180 minus 65, 115. Then we find here these types. Okay? We learn some important points in this chapter. Now I write again some, you write in your notebook these points. Now, tangent to a circle and the point of a contact. Here we learn two words. What is tangent? To a circle and the point of contact. Which point is called contact? Point of contact. And what is called tangent? If a line drawn in the plane of a circle intersect the circle in one and only one point, then the line is called tangent to the circle. Here, if a line drawn in the plane of a circle intersect the circle in one and only one point, suppose it is a circle in a plane. Here line is intersect point line L. So plane alpha, line L intersect the circle at point A, which is one and only one, then this line is called tangent of circle. And the point at which the line intersects the circle is called the point of contact. Is called the point of contact. The point at which the line intersects the circle is called point of contact of the line with the circle. In figure, which point is called point of contact? Suppose O is the center, then A is called a point of contact. The point of contact of the line with the circle. If this figure is like this, line L, here is point P, then O. Point P is contact, the point of contact of the circle. Now, two definitions is here. Please understand these two definitions. A line of circle in a plane is intersect the circle at in one and only one point, then it is called tangent to the circle. And the circle is called the point of the contact. When the point of contact, the point at which the line intersects the circle is called point of contact of line with the circle. A line intersects the circle in one and only one point, then it is called tangent to the circle. And a line intersects the point at which the line intersects the circle is called the point of contact of the circle of the line with the circle. Number of tangents from a point to the circle plane of a circle. Number of tangents. How many tangents from a point in the plane of a circle? Number 1. P is the interior of a circle. Suppose P is in the interior of the circle. P is interior point. Then how many tangents we draw? No tangent, because it is intersect, this line intersects circle in 2 points. Our definition is a line intersects the circle in one and only one point, then it is called tangent. Here it is, these lines intersect P, intersect circle in 2 points. There is no tangent to this circle from the point P. No tangent for number 1. Second number. P is on the circle. Suppose P is on the circle. Here, point P is on the circle. Then how many tangents? In this figure, we know only one tangent. P is here Q. Then we draw only one tangent from this. There is one tangent to the circle from P. How many circles? How many tangents? One tangent. And number 3. P is in the exterior of a circle. P is in the exterior of a circle. P, we know that point P lies in the circle, on the circle or exterior of the circle. Three possibilities. Then P is lies on in the exterior of the circle. Here P. Right, P. Two tangents to the circle from P. How many tangents? Two tangents to the circle from P. What is tangent? A line of circle of a plane of a line in the plane of circle intersect the circle in one and only one point, otherwise unique point, then it is called, the line is called tangent to the circle, and the point at which the line intersects the circle is called point of contact. There is three possibility. Point P lies in the circle, point P on the circle, and point P is in the exterior of the circle. Suppose P is lying in the interior of the circle, then we do not draw any tangent. There is no tangent to the circle from the point P. P is on the circle. There is only one tangent to the circle from P. And P is in the exterior of a circle. There is two tangents to the circle from P. Like this. Suppose it is a circle. Point Q is here. Then we draw only two tangents from this. How many tangents? Two tangents. Okay. In circle, in plane, here two tangents. Here on circle there is only one tangent. There is point on circle. Suppose P is on them, only one point, one tangent. Here Q, here R. Only one tangent from this point. And in the circle there is no tangent to the circle from the point P.